In topic 2, we're going to be looking at relations versus functions. So to begin, I guess we need to understand what these two words mean. So let's start off with relation. So a relation is a set of ordered pairs. And what I mean by that is, well, an ordered pair is a pair of numbers that have an order to them. So for instance, a good example of that is a coordinate on a graph, an x, y coordinate on a graph. That is a pair and they're in an order. The x comes first and the y comes after. So if you had a set of these ordered pairs, so let's say I had xy coordinates of 1, 2, and then another xy coordinate of 3, 4, and let's just do 5, 6. This is a set of ordered pairs, so then that could be a relation. Now, a function is a relation in which each member of the input is paired with exactly one member of the output. So I'm going to leave it at that for now, but this will make more sense once we continue on in this topic. So a nice way to remember what a function is using this visual here of this function machine. Now, what this machine is showing us is we have an input at the top here. So this is the input. And so the input goes into the function machine, and then something happens in the machine, and then out pops a output. So if we look at our definition of what a function is, it says it's a relation in which each member of the input is paired with exactly one member of the output. So in this first example here, we have one input and then we have one output. Therefore, this one is a function. However, in the second one, we have one input again, but this time we had two outputs. So if an input has more than one output, it is not a function. So that's just a good visual to remember what a function is. So now let's look at some other words. We have domain and range here. So the domain is the set of x values and the range is the set of y values. And there's actually 4 different ways to say the exact same thing. So let's do that here. So we have domain. Well, that is equal to x, like we just said up here. And then that's also equal to the input. So our x values are the inputs. And the x values, which are the inputs, are also the same as the independent variable. Now, just below here describes what an independent variable is. So it says these values do not depend on the other variable. So they're independent, they don't depend on anything else. Now let's look at range. So if domain is equal to x, then range is equal to y, which is equal to the output. So the y values are the outputs, and that is equal to the dependent variable. So the dependent variable depends on the independent variable because it changes when the independent variable changes. So as soon as that independent variable changes or the x value changes, then the y value is going to change as well. Therefore, it depends on what the x value is. So let's move on to the next page here where we actually look at relations and functions. So in example 1, it says express the relation, and then here is a set of ordered pairs. Set of ordered pairs. So express the relation as a table, a graph, and an arrow diagram. So all of these ordered pairs here are x and y values. So we could go like this, x, y, x, y. So these can all be plotted on a graph, which we will do below. What we'll also do below is represent this relation in 2 other ways other than a graph. So we can use a table, a graph, and a new thing that is called an arrow diagram. So that's new this year. But first, let's put these ordered pairs into a table. Let's put this relation into the table. So all of the x values are going to go on that left column, and then all of the y values on the right column. So I'm just going to take my first ordered pair here, and I'm going to put my 4 here and my 3 here. And I'm going to do the same thing for all the other ordered pairs in our relation. All right, so I put all of our ordered pairs into the table, so that's one way to represent our relation. Next, let's do the graph. So this is just simple graphing where we plot the x and y values on the graph. So I'm just going to start off with this first one, 4, 3. So I'm going to go to the x value of 4. So that would be right here. Can't really see where I'm pointing. And then I'm going to go up to the y value of 3, which would be right there. So try to get into the habit of labeling every point you put on a graph, because we're going to be doing a lot of graphing and it is very important to label your points. That is something you will lose marks for in pre-cal if you don't label your points on a graph. So I'm going to continue graphing or plotting all these points. So now we have -2, -1. So I'm going to go -2 on the x-axis and then -1 on the y. So that brings me right here, and I'm going to label that point -2, -1, and so on. So I'm going to continue plotting the rest of these. All right, so I plotted all of our points on the graph. So here is the graph of the relation that we're expressing above. Next, let's do the arrow diagram. So this is something new, but it's really easy. What we have here are two ovals, I guess. And in this first oval, we're going to put all of the x values we have. And then in the second one, we put all of the y values we have. Now, the little trick with this is that we don't repeat any of the x or y values. So you'll notice how we have 5 values in the x department and only 4 in the y. The reason for that is if we look at the y values in all of our ordered pairs above, so I'm just going to highlight them. That's a y, that's a y, that's a y, that's a y, and that's a y. You'll notice 2 of them are the same. These two, the -4s. So we only have to write -4 once, and that is very important. Do not write the same number twice in an arrow diagram. And a nice way to organize the arrow diagrams is by putting the numbers from biggest to smallest. So you'll notice that it starts with the biggest number up here and then works its way down. That isn't super important. I won't dock you marks for that, but it's just a nice way to keep things organized. So yeah, we have all of our y values here. We have 3, 2, -1, and -4, and you can see that here, 3, 2, -1, and then the 2 -4s, but we only write that once. And then we have all of the x values in the other oval. We have 4, -2, so here 4, -2, -3, 2, -3, 2, and 0. So all of the values are represented there. Now all we have to do next with the arrow diagram is draw arrows from the x values to their corresponding y values. So let's look at all the ordered pairs we have up here. So we have 4 and 3, so that's why they drew an arrow from the number 4 to the number 3. So next let's do -2, and that goes to -1. So I'm going to go from my -2x value to -1. Then we have -3 to 2, so I'm going to go -3 to 2. Then 2 to -4, so 2 to -4. And lastly, 0 to -4. And that is the arrow diagram. So next it says, is this relation a function? Why or why not? So let's go and look at our definition of a function again. It says a function is a relation in which each member of the input, so remember the input are the x values, so each x value is paired with exactly one member of the output or the y values. So each x value has to be paired with only one y value. So let's look. So an easy way to check if a function is a relation or not is by checking out the arrow diagram and looking to see if any of the x values match with more than one y value. So if we look here, well, 4 only matches with 3, 2 only matches with -4, 0 only matches with -4, -2 only matches with -1, and -3 only matches with 2. So none of the values in the x are paired with more than one value in the y. Therefore, this is a function. So what I'm going to write here is, yes, this is a function because each member of the input, and beside that I'm just going to put the x, is paired with exactly one member of the output. So that there is how we would state whether a relation is a function or not. So now let's look to determine if the following relations are functions using the exact same logic we did before. So personally, I think looking at the arrow diagrams is the easiest way to tell whether a relation is a function or not. So if I'm not given an arrow diagram here, I'm going to quickly make one because they don't take long to make. So for A, let's just quickly make an arrow diagram. So I'm just going to put my two ovals, and then I'm going to put all the x values in one side and then all the y values in the other. So x, we have 5, we have 2, we have 0, we have 2 again. So we are not going to put another 2 in that oval in our arrow diagram, but we do have another 3, so we're going to put that there. We haven't written 3 yet. And then let's do the y values. We have 3, 6, another 3, so we're not going to put another 3. Then we have 4 and 9. So we didn't repeat any numbers and we have all our values there. So now let's take some arrows and connect the dots. So we have 5 going to 3. We have 2 with 6. We have 0 with 3. We have 2 with 4. And finally, we have 3 and 9. So now we have to look, do any of the x values match with more than one y value? Well, the 5 only matches with the 3, but the 2 matches with the 6 and the 4. So because of that, this is not a function. And the reason for that is the input 2 has more than one output. And those two outputs are 6 and 4. So it matches with more than one output. Therefore, this is not a function. So let's look at B. B, they already gave us the arrow diagram, so that makes things a little easier. And let's see, do any of the x values match with more than one y value? Well, the 2 just goes there, 1 just goes there, 4 goes there, 3 goes there, and 5 goes there. So no, none of them match with more than one y value. Therefore, yes, this is a function. And then finally for C, I am also going to do an arrow diagram for this. So I'm going to do my ovals. We have x values on one side and y in the other. And I like to just quickly label these xy, xy, xy because my eyes like to deceive me and confuse me, and I'll write the wrong values. So I'm going to put all the x values in the first oval. So we have -2, 1, 3, 5, and 7. So none of those repeat themselves. And then we also have 4. So now we're doing the y's. We have 4, 5, 6, 8, and 10. So none of those repeat themselves. And these are all going to match up pretty nicely straight across. So now it's very clear that none of the x values match with more than one y value. Therefore, yes, this is a function. Now, the last thing we're going to look at is how to tell if a relation is a function given the graph of the relation. So you'll notice in the above example, we weren't given the graph, we were given every other option. So we were given the table, the arrow diagram, and then the set of ordered pairs. But now in all these examples, they're giving us the graph. And yes, you could go and make an arrow diagram of these graphs. Like you could go find a bunch of points on the graph and then make your arrow diagram, but there's actually an easier method if we were given just the graph. So what that method is called is the vertical line test. So this is used to determine whether a graph is a function or not. And how we use it is we take any vertical line. So if I were you, I would use your pencil or any straight line you have during a test or when you're writing your assignments, and you take it and you run it along your graph. So I'm just going to take this vertical line and I'm going to run it along my graph like this. Now, what you're looking for is if at any point your vertical line touches the graph in more than one spot. So you'll see where my line is right now. It's touching the graph here and here. Now, because of that, that means that this graph is not a function. So in order for a graph to be a function, it needs to pass the vertical line test. And what that test is you take your vertical line and you run it through the entire graph, and it cannot touch the graph at more than one point at any time. So in order for a graph to be a function, you need to be able to run your vertical line or your pencil through the whole graph, and it can never touch it in more than one spot at a time. So let's try another example. I'm going to bring our vertical line down over here. So in example 3, let's determine if the following graphs are functions. So I'm going to take the vertical line and I'm going to run it along this graph. So imagine this is like running smoothly along here. And does this vertical line ever touch 2 points on the graph at a time? The answer is no, it does not. It's only ever touching just one little point on the graph. So because of that, this is a function. So we're going to put, yes, this is a function. So let's try it with the next one. Well, the next one is just the one we did at the top of the page there. So if we run our vertical line along that graph, eventually it's going to touch 2 points. So it touches here and it touches over here. And because of that, this is not a function. Now this next one's a little bit trickier because there's something new with it. So if you're running your vertical line across, you're probably like, oh, this is all good, but I could see right in the middle here, it's touching our graph at 2 different points. But you'll notice that one of the circles is colored in and one of them isn't. So here, I'll just move this out of the way. So the circle up here is an open circle and the circle down here is a closed circle. So it's colored in. Now what an open circle means is that it does not include that point. So it includes every single point leading up to it, but as soon as we get to this exact point here, it is not included in the graph. So here, I'm just going to write a side note about that. So I just wrote that the open circle means that it does not include that point, but it includes every single little point leading up to it until it reaches that point. So if we're trying our vertical line test on this graph and we get to that section where it's touching these 2 points, or it looks like it is, technically it is touching the one down here because it's colored in, but the one up here it is not touching. That point doesn't exist on the graph. Therefore, this graph does pass the vertical line test and it is a function. So I'm going to put yes, this is a function. And let's move on to D. So this time our graph is just a bunch of points plotted, but let's see if any of those 2 points ever touch our line at the same time. So that one doesn't, this one doesn't, this one doesn't, this one doesn't, the next one doesn't, and clearly the next one doesn't. So yes, this graph passes the vertical line test and it is a function. Now our next graph is a circle, and you'll notice right away that our line touches it in 2 spots a whole lot of times. So here and here. Therefore, this is not a function. And then finally, we have F, which looks very similar to C, except now both of these points are colored in, which means that when we put our vertical line over the graph and it hits that spot, so I'm going to put it right there, technically it is touching the graph in 2 spots now because both of those are colored in, so they're both part of the graph. Therefore, this one is not a function. It does not pass the vertical line test. So we looked at a few different ways to represent relations. We have graphs, we have tables, arrow diagrams, and then a set of ordered pairs. And we also looked at how to check whether a relation is a function or not.